in parentheses, we have 1 plus I raised to the n power minus 1. And that's on that whole thing. Make sure you extend is on the top of the fraction. And then it's divided by I. So, let's write down what these things stand for, is the interest per compounding period. So for instance, let's say I had an 8%, that's really high by the way, 8% annual interest, and I was making monthly contributions. That 8% would be 0.08 divided by 12. Okay, so your interest is going to be your annual interest divided by how often you're making your payments. R is the value of the payment. And then N is the number of payments you make. Okay. And just to make sure we're clear, okay, this is the one we're using when you're saving for something, saving for retirement. Okay. So let's say Nate gets out of college and he invests $500 every quarter into an annuity. So he's going to start right away saving for his retirement. So $500 every quarter means that every 3 months, right, quarter of a year, he is going to deposit $500 into an annuity. And the annuity yields, we'll say, 4% annual interest. Okay. So then, let's say I wanted to know how much will he have, I don't know, what's a typical work span, like 25 to 30 years? Okay, let's find out how much, if that's the only thing he does he have after 25 years? Okay, so the future value is what I'm trying to find. I want to know what's the future value of this account, the FV. I know this, I know R. Did I give you the interest rate? Yep, I told you how many times a year. Quarterly is 4 times a year, okay? So let's write down what these things are. What was the amount of the payment that he's making? 500. Okay. His interest was 4% annual interest, but he's putting it in every quarter, so we have to do 0.04 divided by 4. Let's say he was doing it every month, it would be 0.04 divided by 12. Now be careful, because before on the interest formula, this power was just the number of years. I want to know how many times did he make that payment? Well, he did it 4 times a year for how many years? 25 years. So 4 times 25, he actually put it in 100 times. So once we figure those things out, really we're just going to show how we put those into our calculator, okay? So I'll tell you what I do, because it involves some parentheses and it seems to always work with no errors. But this is our setup. We did 0.04 over 4, this 0.04 over 4, and if you want to put in 0.01, that's fine. That parentheses I'm going to raise to the 100th power. Then I'm going to subtract 1 from that whole thing. Okay. So when I put this in my calculator, I do this part first, and then the last thing I do is I multiply by the 500. And so I'm going to just do the top. I do it piece by piece. I'm going to do the whole top. I'm going to hit enter, divide it by the bottom, and then we're going to multiply by 500. If you want to try to put the whole thing in, go for it and see. But I find that there's so many parentheses, especially with like that business, then sometimes we make mistakes. All right, so I'm just going to do this top. 1 plus 0.04 over 4. I'm going to raise it to the 100th. And then make sure you're careful here. If you have one of those calculators that puts things in the power, that you put it back down. I'm going to then subtract 1 from the whole thing. Is that what you got for the top? No? Yes. All right. Now I'm going to divide. Hey, if you want to put 0.01, that's fine. But if you're going to do this business, because sometimes it's not so nice, make sure you use parentheses. Now I divided it by that bottom. And finally, this whole thing is times 500. So this, if that's the only thing he does for retirement, did y'all get that? Do I have to look at anybody's calculators? No? Okay. Now, let's go back, because we should talk about this. How much of that was his own money? Like, how much of that was the 500? Let's compare, because this calculates the money plus the interest. What would I do to figure out how much of that was his own money? Does anybody know? Yeah, remember he did the 500 times 100. So did he get a pretty good return on his investment? Yeah. This is what happens when you, I know you're all young right now, but when you start your jobs, somebody will probably come to you and say, hey, even if it's a little amount, start now. Because if it's a little amount, but you have time on your side, that can add up, even if it's a little amount for investing something. All right, so yeah, he made $35,240 on his investment. All right, do you guys have any questions about that so far? All right, so now let's go to the bad side. What if you have to get a loan? Well, it could be. Sometimes it's not a bad thing because it allows you to do something like go to college. sometimes I'll talk to you more, and then you can just ignore me if you want, about why you should never buy a brand new car because it's not worth the money. And also how you don't, if you can, you don't want to get a loan because the bank is taking your money. We think about, oh, what's my payment? Yeah, but when you look in the long run, gosh, that was really sickening. When I looked at my house payment and I figured out over 30 years how much interest I'm paying the bank, it's a lot of money. It's like double the value of your house. All right, so this is called present value. So the word present meaning right now, you are getting some money in the present. This would be a loan, a mortgage. This is also how a credit card works. They're giving you money, they're loaning you money, and they're going to charge you interest. All right. I'm going to write the things down. The R, the I, and the N are the exact same things as before, so I'm not going to write those things down again. But here's the formula. The present value is the amount of the loan. So typically, this is a little different because in this problem, we're going to know the loan amount. R is the payment, and that's the thing usually that we're trying to find. So this formula is different. It does 1 minus, in parentheses, 1 plus I to the negative n power. And that's on the top. All over I. Okay. So let's say you're like, sweet, I have a job, I'm going to buy a car. How much is the, let's say we're going to just bite the bullet, we're going to brand stinking new car. How much does that cost?
Too much.
Too much. Give me a number. Yeah, that's a cheap car actually now. Okay, so let's say we'll use Nate again because that covers 2 people. This is one of the things you're going to do for your project is you're going to buy a car. You're going to pick which one you want. Okay? You're going to look up a loan. Okay? So he buys a $40,000 car and gets a loan. And he gets a really good, he must have really good credit. He gets a loan with 2.9% APR. Have you guys ever seen that on commercials for cars? Do you know what it means? Annual percentage rate? Yeah, that's what the APR means. And they will do some 6-year loans, but we're going to do a 5-year loan. So they actually also do 3 or 2-year loans, but it costs, your payment is a lot more. And he's going to do this for 5 years. Let's calculate his monthly payment. Okay. So again, before we start plugging things in the formula, let's figure out what we have. So this time I'm trying to find R. So at the end, I'm going to do something, instead of multiplying, I'm going to do some division. The PV, what I'm going to put there is the loan amount, and that's $40,000. The I, so what they do with an annual percentage rate is they want to get their money more often. So this is how this works. 6.029, but they get a little bit of it basically every month.